Are you curious about how generators work? Let's delve into the fascinating world of generators and uncover the simplicity behind their operation. Although generators and motors have similar structures, their functions are completely different. One converts mechanical energy into electrical energy, and the other converts electrical energy into mechanical energy. First, you must know that when the total magnetic flux passing through the conducting coil changes, induced electromotive force will be generated in the conductor, which can be simply understood as voltage, generating an induced current in the conductor coil. This phenomenon was first discovered by Faraday. In order to understand it better, let's take a look at this simple model of a generator. The metal coil in front of it is called a power transmission. It generates electricity by rotating between two magnets to provide mechanical power for the power transmission. It can be a turbine, a steam turbine, etc. The power transmission is connected to two metal slip rings, which rotate together, and the slip ring is connected to the brush so that current can be transmitted. When the rate of change of the magnetic flux is zero, no current will be generated. However, as the power transmission rotates, the magnetic flux begins to change, forming a current through 4/4 of a cycle. After the change of the magnetic flux reaches the maximum value, the current also reaches the maximum value. As the power transmission continues to rotate, the change of the magnetic flux gradually decreases, so the current also decreases. When the yellow power transmission part reaches the bottom, the power transmission is parallel to the magnet, resulting in a change rate of 0 for the magnetic flux. At this time, the current is also 0. The current change in the second half of the cycle is the same as that in the first half, but the current direction is exactly opposite. The curve of the entire cycle is like this. This is alternating current. The biggest difference between alternating current and direct current is the direction of current. In order to prevent the change of current direction in the DC generator, only one ring called a split ring is used in the slip ring part. However, the friction between the brush and the armature in the DC generator can easily cause wear. The above is just theory, but in practical applications it will be much more complicated. This is a small, disassembled DC generator. The middle part is the armature. There are two permanent magnets on the outside. A metal coil is wrapped around the armature. When the armature rotates, the coil cuts the magnetic field to generate electricity, but it needs to be noted that it is not that easy to use in large power plants. First of all, due to energy transmission efficiency and transmission distance, most power plants use alternators. In order to generate 150 megavolt amperes of electricity, the generator will have a very high speed, reaching 3000 RPM. If we were to place the beam winding of such a large generator on the rotor like the small DC generator just now, it would be very dangerous. The noise in the surrounding area would be equivalent to an earthquake, so we have to change our thinking. We can place and fix the power transmission group on a nail. This will not only make it easier to provide cooling, but also make it easier to collect large voltages and currents. If this is the case, the rotor can only be designed as a magnet to provide a magnetic field, but the problem arises again. If a large generator is made of a permanent magnet, it is not suitable. First of all, it is difficult to install because the magnet is huge. It may suddenly be stuck somewhere and cause huge damage, and you can't separate it. Secondly, even if you use up all the energy, it may cause huge damage. Tiger Force installed it accurately on the rotor. Another problem is that the magnetism of the permanent magnet will slowly decrease over time. The magnetism cannot be controlled, but there are ways. We all know that when a metal coil is connected to DC, the coil will generate a magnetic field exactly the same as that of a permanent magnet, and we can control its magnetic field by controlling its power supply. Now we install a winding on the rotor that can generate a magnetic field, which is also called a particle winding. Then, when DC current is applied, a constant magnetic field is generated. At this time, we use a turbine to provide mechanical power to the rotor. For better observation, we first show only one set of coils on the stator winding. When the rotor rotates, the magnetic field lines cut the stator winding. The stator winding will produce an electric waveform formed by the change of the magnetic flux. The simple model we talked about at the beginning of the video is the same. The difference is that now we have 3 sets of windings on the nail. The phase angles of the 3 windings are all 120 degrees. When the rotor rotates, The three windings produce electricity at the same time. This is the so-called three-phase. However, this kind of rotor is only suitable for use in slow-speed power generation equipment, such as hydroelectric power generation and wind power generators. Because the gap between its magnetic poles is large, high-speed rotation will cause imbalance and even cause the generator to fall apart. For example, the rotor in a thermal generator is set into two magnetic cylindrical rotors to meet the high-speed rotation of 3,000 revolution per minute. And the rotor rotation speed determines the frequency of the power grid. In many chargers, you will find 50 to 60 hertz. The word hertz is the grid frequency. It depends on the national or regional standard. The grid frequency in most countries is 50 hertz. Its calculation formula is the generator magnetic set number multiplied by the generator speed and divided by the constant 120. So, next time you see a generator, you'll know it's not just a box making electricity. It's a marvel of simplicity, wrapped in coils and magnets, doing the electric boogie. If you found this journey through the world of generators electrifying, don't just keep it to yourself. Spread the wattage by liking, commenting, sharing, and subscribing to keep the sparks flying. Let's power up together.